Okay. So, hi all of you. Good morning. I'm happy to meet you all at 7:45 today. Sharp. Is the screen okay to all of you? And am I audible to all of you? If yes, please type in the comment box. Am I audible to all of you? If yes, please type in the comment box. Am I audible to all of you? If yes, please type. Am I audible? Is it clear? Is the board clear to all of you? Yes? Okay. So basically in yesterday's lecture, we have dealt with the concept of limit, and we have seen what's the definition of some neighborhood and some evaluation basic definition of limit. So now in today's class, we'll be looking at some standard limits and basically some questions that appeared in GATE exam, and we'll be looking at the techniques to solve that questions. And apart from that, we'll be looking at the concepts of continuity and differentiation. And we'll also see what's the physical meaning of derivatives and all in this lecture. And if time permits, we'll go for Taylor series also. Okay. So let us start our lecture. So if you remember yesterday's lecture, we have stated the definition of limit, and of course for all mod of x minus a less than epsilon, where epsilon is greater than 0, I told you, I think I have used this delta here. Let us use the same notations so that you may not get confused again. For all delta greater than 0, there exists epsilon such that f of x minus L under modulus is less than that epsilon, where epsilon is also less than 0. And of course, this is also a less than symbol. Correct? So this is the definition of limit that we have seen, and we have started seeing into some standard graphs. So in today's class, we'll see some standard limits at the beginning, and before that seeing of that standard limits, we could see into 3 more standard graphs that were asked in some interviews and that appeared in GATE a few times. Okay, so continuing with our discussion yesterday, let us try to continue the graphs. Y is equal to 1 by x. Now, if you want to sketch this curve, y is equal to 1 by x, see here, first of all, the standard procedure is to set up the axis. Once you set up the axis, this is 0, x, minus x, y, and minus y. Now, one thing is very clear. If this x is positive, definitely this y is also positive. Similarly, if this x is negative, y is also negative, which means x and y both are simultaneously either positive or negative, which means the graph lies only in the first and third quadrants. Correct? Because in the second and fourth quadrants, one of the variable or one of the ordinate is positive and one of the ordinate is negative. So we have the graph only in the first and third quadrants. So y is equal to 1 by x. Curve looks like this because it's known fact, as this x keep on increasing, this y keeps on decreasing. Or similarly, if this x keep on decreasing, this y keep on increasing. Correct? Similarly, if you come to the third quadrant where x is negative, the curve could look something like this. So this is how y is equal to 1 by x graph looks like. And one more thing, if you see, if you see, these lines didn't touch here because we can't denote infinity on the x-axis. Correct? So these are graphs of y is equal to 1 by x. Now, could you tell me one thing based on this? If I ask you, what is the value of limit x tends to 0, 1 by x? Based on this graph, could you tell me the answer of this? Take a moment and write the comment. What could you feel as the answer for this? Limit x tends to 0, 1 by x. Any comments for that? Limit x tends to 0, 1 by x. 1 not defined. Good. It's actually not defined, or you can say it does not exist because yes, Subramaniam Medical, it doesn't exist because if you see this graph clearly, I told you clearly, whenever you're evaluating limits, you should look at both right limit and left hand limit. Correct? So if you consider this right hand limit, x tends to 0 plus, means basically x is in the right neighborhood of 0, then this 1 by x, this curve 1 by x is tending to positive infinity. So this is plus infinity. Correct? Similarly, if you consider the left hand limit, limit x tends to 0 minus 1 by x, on the left neighborhood of 0 means somewhere here, the value of this function is minus infinity. Correct? The value of this function is minus infinity here. So the left neighborhood, the value is minus infinity, and you see yourself that both the limits or both the values doesn't agree with each other. So basically this limit does not exist, and this question was asked like 3 to 4 times in GATE examination. you would take care of. Okay, generally people will be intended to put this infinity here, and that was also given as first option in that question. So please be a bit careful. Okay, next. Do you need some time to take this? Please take it. The graph of y is equal to 1 by x and limit extends to 0, 1 by x does not exist. And yesterday I was seeing, I was going a bit speed. Okay, in today's class I'll go a bit slow and I'll continue this. Okay, if you have any more complications at any moment, you can write in the box so we can judge. Okay, now with the help of the curve y is equal to 1 by x, could you trace yourself what's the curve y is equal to minus 1 by x? How could the graph of y is equal to minus 1 by x looks like? Could you try it for a while? It's simple, correct? Because pattern looks same, but quadrants changes. Because if this x is negative, again this y is positive because of 1x minus sign in the numerator. Correct? Similarly, if x is negative, y is positive, and if x is positive, y is negative. Means to draw the graph, let us again set up the axis 0, x, y minus x, and y and minus y. Now, if you see, the signs of this y and x are opposite to each other. Correct? In the previous case, where y is equal to 1 by x, we have same signs for both x and y. But now, in this case, we have opposite signs for x and y because of this minus sitting here. Now, that means the graph that you're going to draw should lie only in the second and fourth quadrants. Correct? Because second and fourth are the quadrants where both variables have opposite signs. So, which means the graph should sit only in the second and fourth quadrants. And if you try to draw this graph, it could look something like this. Okay, where x is positive, y is negative. Similarly, when x is negative, y is positive. Okay, now generally we use this process. If you are from mechanical background, you could deal with thermodynamics. Then if you see the for isothermal process, you have some definition like PV is equal to constant, correct? But of course, when you are dealing with an ideal gas. So this PV product is constant, which is similar to the curve y is equal to 1 by x, which implies xy is equal to 1, where this is a constant. And you have seen yourself drawing the isothermal curve on a PV diagram in this fashion. Okay? So please make a note of this point. This is y is equal to minus 1 by x. Okay, clear? So please take it. Now, going ahead, let me draw the graph of y is equal to x into sine x, which was asked one time in GATE examination. Y is equal to x into sine x. Could you give a try before I draw the actual graph? Because I have also asked you in yesterday's class to work out this graph. Correct? So could you try a moment? And yesterday's class notes was uploaded. I gave a link in the comments box of yesterday's video. Please find there. Okay. It's basically a Telegram channel of Engineers Hub. You can visit. You can get the notes PDFs over there. Now, continuing with the definition of this y is equal to minus 1 by x. Before moving to next graph, I would like you to get the value of limit x tends to 0 minus 1 by x. What could be the answer? Limit x tends to 0 minus 1 by x. What's the answer for this? In between x and minus x. No, not exist. Correct. Ramshekar, it's correct. The value does not exist. Again, you can see here in the right neighborhood, the value is minus infinity, and in the left neighborhood, value is plus infinity. So, limit x tends to 0 minus 1 by x does not exist. It's a simple thing to analyze. Now, coming to the graph of y is equal to x into sine x. Correct? So, do I need to retain this page for y? It does not exist because if you see on both two different neighborhoods, the value of limits is different. Okay, so this limit also does not exist. Correct. Many of your writing does not exist. It's okay. I'm happy for that. Now, so I hope you have given enough time on this. Now, first of all, to trace any curve, x into sine x is not a curve which we deal very often. So to trace this curve, let us follow our standard procedures. First of all, set up the axis. Okay. And this is minus y. Now, this line could be 0. Okay. And of course, this is your positive x-axis and this is negative x-axis. Now, what's the second key point that I mentioned in yesterday's class? You need to identify the maximum and minimum values of this particular function. Correct? Once you know what's the maximum value of this function and minimum value of this function, then definitely you could bound the graph in some lines or curves. Now, one thing to identify the maximum and minimum limits of this x into sin x, we all know minus 1 less than or equal to sin x less than or equal to 1. Correct? Whatever the values you put in place of x, definitely the sin x lies in between minus 1 and 1. Now, if you multiply this complete inequality with x, what would you have? Minus x less than or equal to x into sin x less than or equal to x. Correct? Which means this x into sin x always lies in between the lines minus x and y is equal to minus x and y is equal to x. So first let us trace out the lines y is equal to minus x and y is equal to x. And yesterday while drawing the graph of mod x, we have seen the line y is equal to x. Let me change the color so you could feel the difference. Y is equal to x looks something like this. And of course, let me extend it to the bottom as well. And the y is equal to x. Okay. Now, similarly, if I try to draw y is equal to minus x here, again, this y is equal to minus x could look something like this. And to the top onto the second quadrant, y is equal to minus x. Correct? Now, one thing is very clear. You have seen this minus x less than or equal to x into sin x is less than or equal to x, which means whatever the graph you are drawing, that's lying in between these two lines. Yes or no? Now, you know, sin x is a repetitive function, means it has a pattern which is repeating on itself. So, try to draw the graph of sin x in between. That's the answer. Now, see, I'll be sketching it. 0 and it goes. And it goes on like this. This pattern keeps on repeating. Now, if you see, this value is again pi because you know sin pi is 0. Let me remove this 0 here. So, this is 0 and now this value is pi and again this is 2 pi because you know if you put x is equal to pi, 2 pi for all integral multiples of sin x, for all integral multiples of x, sin x gives you 0 and this curve will be cutting the x-axis of it. So this is how the graph of x into sin x looks like and it's been asked in interviews a lot of times to sketch this function. Okay, so please take this and if you have any difficulty, please you can write in the box. And the link for the Telegram channel I have already uploaded. I have already commented in the comment box of first video. You can go there. Okay. Clear? Took this? I could wait for a moment. Please take. And you can see this x denotes the increase in magnitude of this function and this sin x denotes the pattern of repetition of this function. Generally, you see in vibrations and all these things in mechanical. Correct? Now, before going to some standard limits, discuss some standard limits, I would like to give you one more graph, the last graph of our class, which is really important because there is a question based on that graph that came many times in GATE examination. So, that graph that I am going to talk about is y is equal to sin x by x. Please try this graph, all of you, for a while. Before you try the graph of y is equal to sin x by x, I would like to explain this graph once again. Vijay Sai, look here. So, first of all, you need to, after setting up the axis, you need to look for the limits that's bounding the curve. So, if from this analysis, you came to know that this x into sin x is always lying in between minus x and plus x. Now, this, after setting up this pink lines which I have drawn here, now this x denotes the increase in the magnitude of this function, and this sin x denotes the pattern of repetition of this function. So in between these lines, I am drawing my sin x pattern so that I could get the graph of x into sin x. There is one question: when we are multiplying x with sin x, it will become positive in x-axis. Need not be. For example, if I take value like minus pi by 2, or for example minus 5 pi by 2. Now, if you see, this minus 5 pi by 2 is again corresponding to some negativeness, and also this negative value when multiplied will get you to positive x-axis. Okay. Now did you all try this graph? Y is equal to sin x by x. Okay, let me try now. Now again, following our standard procedures that we adopted, setting up axis 0 minus x. Sorry, this is plus x, then minus x. This is y, and this is minus y. Correct. Now, if you see, again, finding the upper and lower limits for this function sin x by x, and we all know this minus 1 is less than or equal to, this minus 1 is always less than or equal to sin x is less than or equal to 1. Now, if you divide all this inequality with x, this implies minus 1 by x less than or equal to sin x by x less than or equal to 1 by x. Correct? Which means this sin x by x is always lying in between the curves y is equal to minus 1 by x and y is equal to 1 by x, which we have dealt before. So now if you see, let us try to sketch the curves. Y is equal to 1 by x and y is equal to minus 1 by x. Y is equal to 1 by x is something like this. Let me draw it more steeper so you could see the change in it. Well, and this is something like this. Y is equal to 1 by x, and now tracing the curve y is equal to minus 1 by x, which we already did. It looks this. Now, what are the graph you draw? It should lie in between this bounded area. Okay? So now this sin x again repeats the pattern, and this increase in the magnitude of x will totally decrease this function. Okay? So drawing the pattern of sin x inside the graph. Now, if you see, this is something similar to the graph which you see in case of damped vibrations in mechanical. I think even civil people deal with that. Now, this is the graph, how it looks like. Now, if you see one thing importantly here, I would like to show you one point. If you see, I didn't touch my graph to y-axis. Okay? Did I touch it? No. Because if you go back a bit to the initial screen that we are discussing, yeah, here it is. If you see, here I am dividing this inequality with x, correct? And division with 0 is not defined, which means if I am able to divide this graph with x, this x should not, this function sin x with x, this x should not be 0. Correct? So that's why at 0, this function doesn't have a value. But there is something value on y which is very close to this, and the value of that y coordinate, which is here, is minus 1. The value, this is plus 1 because positive x-axis. So this value is plus 1. We'll show in a short time how this sin x by x near to 0 is 1, and that gives one standard result. Limit x tends to 0, sin x by x is 1. Okay, we'll see shortly how this is happening and all. So for the time being, this is how you sketch the graph sin x by x. Today's class is from nearly 7:45 to 11:45. Actually, on weekdays, we are planning at quite small lectures because some of the universities are giving their semester exam online courses to the students. So we could plan these lectures only before and after the college hours. But on Sunday, we could go for some long class. So today's is like 7:45 to 11:45, some 4 hours of class. Okay, taken this curve? Clear? Next. Now that we have seen some important graphs that we deal with in calculus, and now we'll go for some standard limits in calculus, okay? And before going for that standard limits, let me give you some properties of limits. Now we have seen how to evaluate limit of a single function. Now if there are some combinations of functions, let us see how to evaluate them. For example, see here, if f of x and g of x are two functions, defined in the deleted neighborhood of A. Deleted neighborhood of A. Then because we know we define limits always in the left, in the neighborhoods or deleted neighborhoods of the point where we are talking about. So then the first point could be this limit extends to A, f of x plus g of x can be written as limit extends to A, f of x plus limit extends to A, g of x. And of course, when there is a minus sign here, you could still use that minus sign here. Okay, next. Limit extends to, let me write it clearly. Limit extends to A, f of x by g of x. This can be written as limit extends to A, f of x divided by limit extends to A, g of x. But of course, with the case here, this g of A should not be 0 alone. Both f of A and g of A can be 0 simultaneously, but g of A alone can't be 0. Okay, because division by 0 is not defined as well. So these are two properties of limits that I could take care of now at this moment. So see here. Okay, so now there is one important result in limits. For example, the result that I'm going to talk is limit extends to A, f of x into g of x exist even if one of the limits limit extends to A, f of x and limit extends to A, g of x. G of x does not exist. Means if limit extends to A, g of x, let us suppose there is a multiplication of two limits. Let us suppose g of x is such function such that at a particular point A, this limit extends to A, g of x does not exist. Then there can be a chance where this limit will still exist. For example, if you see, let f of x is equal to x, correct? And g of x is equal to 1 by x. Now, if I calculate at the point 0, limit at point 0, we have limit extends to 0, f of x is equal to 0. Directly, if you put this x here, limit extends to 0, x will be always 0. And limit extends to 0, g of x, which is limit extends to 0, 1 by x, does not exist. We have seen when discussing the curve of y is equal to 1 by x. Correct? Now, this is a case where for one function limit exists at a point, and for other function limit does not exist at a point. Now, if you multiply these two curves, for example, f of x into g of x, if you consider, now what is this implies? What is f of x into g of x? X into 1 by x. So we can cancel these two and can write 1, and limit extends to 0, f of x into g of x is equal to limit extends to 0, 1, and limit of a constant is the constant itself. So the answer is 1, which means you can see that out of these two, if one limit does not exist, even in that case as well, the combination of multiplication can have a limit at a particular point. Okay, this is one important result in calculus with which we deal many theorems. Okay, so please take a note of this. And I am telling you again, the link for yesterday's notes has been uploaded in the comment box of yesterday's video. You please go over there. Okay. And I'm happy to see you all at 7:45 today. There are no technical issues today. So, okay. And if you don't have any previous background of class 12 or something like that in mathematics, you could always go for one good book of NCERT textbooks of class 11 and 12 so that you could quickly brush up your basics. And this course is intended for all engineering students who are about to write their semester exams or applying for competitive exams as well, like GATE and other PSU exams, because we deal everything from the basic. Okay. And the content of the syllabus will be in the format of GATE syllabus. Okay. Few branches have slight syllabus variations, but don't worry, we'll cover all the variations in individual modules. Sandeep Kodamanchali, yes. Sin x by x looks like cosine graph. Yes, of course. But if you see in cos x graph, for all the loops, the magnitude is same. But here, since there is a division by x, the magnitude keeps on decreasing as you go along x-axis. Okay. Since sin x and cos x have same pattern of repetition, they look same. The only difference you need to find is magnitude difference because of the division with x. Okay. You can look at the cos x graph that I gave you yesterday. Okay, taken here. Now let me write some standard limits. And if you could need some more time, you could pause the video for a while. It doesn't give you a big change. Now some standard limits. And out of all these limits, many a times questions have been asked in GATE examination, and many questions can be answered basically by knowing all these techniques. So first limit that I would like to give you, limit x tends to a, x power n minus a power n divided by x minus a. What could be the answer? Any guess for you? Okay, the answer is n into a power n minus 1. Now, second limit, limit x tends to a, x power n minus a power n divided by x power m minus a power m. This is n by m into a power n minus m. Okay. See, I'll be definitely, clarification, it's correct, n into a power n minus 1. Sandeep, it's a bit wrong, 2a, the actual answer is this. Okay. Next. Third limit. Limit x tends to 0, a power x minus 1 by x is log a to the base e. Don't worry, I'll be giving you how these values are coming in a short time, because right now to show you how these values are coming, we need to have a bit knowledge on derivatives, which is not I've been discussing here. So after a couple of after 20 to 30 minutes of class, I'll be giving you some derivatives so that you could evaluate all this. Okay. Next, 4. Limit x tends to 0, e power x minus 1 divided by x. What could be the answer? 1. Next, 5. Limit x tends to 0, e power mx minus 1 divided by x. This is m. And of course, if you put m value as 1, you will get the above limit, which I stated here. Next, limit extends to 0, 1 plus ax whole power 1 by x is e power a. Okay, next. Limit extends to infinite, 1 plus a by x whole power x is again same as e power a. Clear? So take these formulas. I'll be giving you some more standard limits. Okay. I think it's better if I stand here. You could see the complete screen. Yeah, Vivek Verma, it's correct. E power a is the answer. I'm happy that a lot of you are following the class and typing the answers in the comments when I ask you questions. I'm happy for that. And please do that till the end of this course because that would actually help you a lot. Okay, can I move ahead? Now, continuing with the standard limits. Eighth limit, limit x tends to 0, sin x by x is equal to 1, which I have stated here, and I'll show you in a short time why this limit x tends to 0, sin x by x is 1, 9. And similarly, limit x tends to 0, tan x by x is also 1. Okay. Then 10th, limit x tends to 0, 1 minus cos x divided by x square is equal to a square divided by 2. Now let me write this 2 a bit clear so we could see the things. Okay, next. Could you guess what could be the this little thing? X tends to infinity, sin x by x. Could you guess what could be the answer for this limit? Because this is a standard limit. Generally, you might have know of this limit, 8th limit. But now, what's the answer for 11th limit? Limit x tends to infinity, sin x by x. Yeah, correct, Sliva. It's 0. Because if you see, whatever might be the value of x, this sin x is always a finite value in between minus 1 and 1. Correct? Let me write here. A value in minus 1 to 1 divided by infinite. The answer is 0 because numerator is a finite value and answer is 0. Yes, all of you are writing it correct. Pawan, Annapurna, Monica and all. Thank you. Now, 12th limit. Limit extends to 0 or basically we could write one thing. Limit extends to 0, sin inverse x divided by x. Correct? All of you are following well? Limit x tends to 0, sin inverse x by x. The answer is again, what could be the answer for this limit? Yeah, any guess in the comment box? 1. Correct. The answer of this is also 1. So like this, we see some standard limits, and one important limit that I could discuss at this moment for you, limit x tends to 0, a power x plus b power x divided by 2 whole power 1 by x. The answer for this is square root of a into b. Okay, this is one very good result that you obtain in calculus. This 13th limit, limit x tends to 0, a power x plus b power x by 2 whole power 1 by x is square root of ab. Basically, if you substitute 0, you'll be getting 1 to the power infinity form. We'll see why this limits, why all these results are coming after we discuss derivatives. Okay, but at this moment, I'm giving you this answer, these results. And it's not necessary that you all, you need to memorize all these results in a single go. It's not mandatory. As time goes on, you will be learning these things. Okay, so next, I would like to write one result. Limit x tends to 0, which is basically the extension of the 13th limit. A power x plus b power x plus c power x divided by 3 whole power 1 by x. Could you guess what's the answer for that? See, when there are two variables, two constants included here, the answer is square root of ab. So when there are 3 constants involved, what could be the answer? Any guess from your side? ABC? No, it's wrong. I think something along with ABC could be there, because you see the square root over there, correct? So what could be this time when there are 3 variables? It's cube root, correct? So the answer is cube root of ABC. Okay, or ABC, yeah, cube root of ABC. Divya Potedi, it's correct, cube root of ABC. Fantastic, all of you are writing it right now. So these are basically some standard limits, some 14 limits that could help you out during the evaluation of different limits and all these things. Okay, so now I would like to sustain my discussion on limits here, because to show you these results, I need help of some differentiation formulas, which I could discuss now. Okay, so this is cube root of ABC. Okay, let me go here. Now, concept of continuity. Please be careful and learn this concept of continuity. Okay, yeah, cube root of ABC, all of you have made it correct. Now, this concept of continuity. Now, what is continuity and what's the difference between this continuity and limit? Let us see here. Let me define this as I have defined for limits. A function f of x is said to be continuous at the point x is equal to a if limit extends to a, f of x is equal to f of a. This is the mathematical condition for the existence of continuity at a point. Now, why this condition came? Means what is this limit and this functional value telling us? Let us see in detail now. Let me try to draw the graph here. Now today, I hope you can see the graph clearly. We have a big scale. 0, y, then this is x, then this is minus x, and finally this is minus y. Okay, now see carefully. Let me draw a function that I discussed yesterday. Or let me use the different color so we could see it. See carefully. Let us suppose this is the curve y is equal to f of x. Okay. Now forget about this condition for a while and look at the graph, and let me also enlarge this graph so that I could bring this as a main point of interest. Okay. Now this is y is equal to f of x curve. Now if you see, this is the point x is equal to a. Okay. Okay. Now the main difference between continuity and limits is during limits we talk limits in the deleted neighborhood. Means we don't consider the existence of point a. But in continuity we considered f of a, which means we are talking about the functional value of f of x at x is equal to a. And let me tell you, this value is again L, which we discussed yesterday, correct? And I told you clearly this L doesn't have any interaction with this f of x. This L is just a real number on y-axis, correct? This is what I told you yesterday. Now see here, this function is not continuous here because you can clearly see there's a break in this function. Like for y is equal to 1 by x, if you have seen at 0 there is a break, one end is going to minus infinity and other end is going to plus infinity. In a similar fashion, this function has a break, but this f of a, let us suppose it is defined somewhere here, and this value is f of a. Okay, generally you see functions like this, right? F of x is equal to 1 by x minus 2 when x not equal to 2, and something like 8 when x is equal to 2. You see some split functions which are defined like this. Generally at the points where this function gets failed, they'll define with some other value. Correct? In a similar case, at x is equal to a, there is no value for this function, and I mean the function is discontinuous, and it's mentioned here. This I have written this just to give you the idea. Okay. So now let us talk the concept of limit again. What is the limit? What is the definition of limit? As x tends to this a, this f of x should tend to L. Correct? Now let me denote that for you. I have used this color. Okay. Let us suppose your x is initially here, then this is your f of x value. Correct? Similarly, if you keep on moving this x towards the right, from this point to this point, you have seen your f of x have got shifted from this point to this point. If you shift a bit more, this is f of x again, new f of x, which means one thing is very clear: as your x is moving towards this a, this f of x value is moving towards this L. Correct? Similarly, on the right hand side, if you consider for this, if this is your x initially, then this is your f of x. Now, if you start moving your x towards a, this is again f of x, which is coming down towards L. So, in both the instances, as x is coming towards a, this f of x, which is here, is moving towards this yellow line, which is the value L. Correct? Which means here, still in this case, we can say limit exists. Correct? Because as per definition of limits, what do we have? As x tends to a, f of x should tend to L. That's it. From both the directions, and it's tending. Correct? Because we define limits when we define limits in the deleted neighborhood of a, and we don't bother whether this function has a value at x is equal to a or not. But now, for this function to be continuous, you see here clearly this function is discontinuous. There is a gap here. There is a breaking in the function. Correct? Now, if this function has to be continuous, let me tell you one thing. If this point comes here like this, which I'm showing now, if this point comes here like this, then will the function get continuous because this point is connecting the two ends? Yes. So mathematically, geometrically, if this point coming here, mathematically that indicates this f of a, which is situated here, is coming somewhere here. Correct? If this point is coming here, then this f of a should come to this L. Yes or no? And which means if both these points are equal, when this point gets here, this f of a should be equal to L. Correct? And what is L from our definition? Limit x tends to a, f of x. Correct? So for continuity, this L should be equal to f of a, and we get this relation: limit x tends to a, f of x is equal to f of a, which I have stated a moment later. Yeah, I think you can see the complete analysis now better. Okay. I will give you a minute time for this. Please take a note of this. And this is the same condition which I have obtained here for the continuity. Okay. Please take a note of this. Just a moment here. Okay. I think I'm blocking the board. You can take it. Let me make it a bit enclosed so you can see the things. Okay. Now I hope there is no difficulty. How do you differ continuity from math and fluid mechanics? Trinath Sanket. See, yeah, good question. Look here. Mathematically, continuity resembles without breakage of any point, without breaking of the function at any point. In fluid mechanics or in core sciences, continuity means, for example, if you look at continuity, generally mass conservation is considered. Means if you, for example, if this is a pipe in which fluid is flowing, at every point of this pipe, inside this pipe, there is some fluid particle that is flowing, which means there is no empty space in this. That's what you define continuity, and concept of continuum is getting from there. Okay, so shall I move ahead? Or you need some more time? We'll deal differentiation in a short time as well. Manohar, yesterday's notes was already, I gave the link for yesterday's notes in the comment box of yesterday's video. You could go there in the channel of engineers. Clear? So shall we move ahead? Okay. Okay. So we have seen what's the mathematical condition that is needed for the continuity of a function at a given point. Now, at this moment, we consider differentiation. Differentiation. Basically, the art of finding the derivatives. Correct? Now, before going straight away to the differentiation, let me ask you one thing. What does this equation represent? In a two-dimensional coordinate plane. What does this equation represent in a two-dimensional coordinate plane? Comment. No comments. So you have never seen such an equation in your real life. What does this equation represent in a two-dimensional coordinate plane? Straight line, Lebel equation. It's not Lebel equation, it's linear equation. Okay, yeah, straight line, correct. So this is a straight line equation. Now if I ask you what's the slope of this straight line? What is the slope of this straight line? Yeah, all of you are getting it correct. Sanya, Sandeep, Vijay Sai, it's a straight line. Now what's the slope of this straight line? Ax plus by plus c is equal to 0. Minus b by a. Y by x minus a by b. Minus b by a minus a by b. Y by x and all. So I think some lot of battle is going on between minus a by b and minus b by a. Let us sort it out. Is it minus a by b or minus b by a in short time? Okay. But one of these two is correct. The actual answer, of course, about the situation is this minus a by b. But and this is a wrong answer, of course. So let us see why this is minus a by b and all these things. Just this is for your understanding, just on a school thing. Now, the derivative of f of x at any point provided the function should be continuous. Of course, we'll show you shortly why the function should be continuous. Is given by f dash of x. If you are generally denoting this y is equal to f of x, then dy by dx, which you generally denote, is limit h tends to 0 f of x plus h. Let me clear this plus and this. X plus h minus f of x divided by h. Okay, this is the standard evaluation formula for finding derivative of any limit, any derivative, and this principle, this result is called first principle of differentiation. First principle of differentiation. Okay, and this is called first principle of differentiation because with the help of this limit, we could evaluate any derivative of any function as long as the function is continuous. So now let us see how this box came, means basically this formulation came. Let us try to see here. And again, let me enlarge this. Okay, let me write it here in the beginning. 0, x, and this is y, and of course this is minus x. And this is minus y. Now, let me zoom this curve so that you could have a better idea on the graph. Okay, I hope it's clearly visible to you. Now, let us suppose there is a curve y is equal to f of x. Y is equal to f of x. Correct? Let this point be x. If this curve is y is equal to f of x, what could be this value on y-axis? If this is x, this should be f of x. Correct? Now, if this point, which is located over here, is x plus h, this is giving a double plus sign, x plus h, what could be this value that is situated here? F of, what could be the answer? Write down. If this is x plus h, what's the answer? F of No comments. What would be this value? If this is x, this is f of x, then if this is x plus h, what would be this value? Yeah, Tanusha, it's correct. F of x plus h. Correct. Now, what's the fantastic? All of you are writing it correct. Now, see one thing clearly. What's the meaning of dy by dx basically? If I'm writing dy by dx, what's the meaning of that? For a given change in x, what is the corresponding change in y? Means if I am changing my x by this amount, what is the change in y? That's what your dy by dx tells you. Now see here, if I write delta y by delta x, means basically change in y by change in x. What would be the answer? Change in y is this part, which is f of x plus h minus f of x, f of x plus h minus f of x divided by, what is change in x that you have? X plus h minus x. So which is, and let me write completely here for the beginning step. So x gets cancelled, which means delta y divided by delta x, means change in y for a given change in x is given by f of x plus h minus f of x divided by h. Correct? Now, one important thing, generally we talk about limit, continuity, all these things at a particular point. Okay? So similarly, if you want to talk differentiation at this, no sound? Okay. I think there's some technical issue here. Just a second, let us rectify this. Mic is on actually. Yeah, sorry for this. There's some issue here with the voice. Now I'm audible to you. Is it okay now? Please mention in the comment box if it's okay, if it's audible to you. Okay? Yeah. Okay, fantastic. See here, there's small issue with the mic. It's okay. So now, this is the point till here, and I hope you have taken these notes in the meantime. Please take it if you don't. Now see clearly. Okay, thank you all. Now see here. Now if delta y by delta x is f of x plus h minus f of x divided by h, and now if I want to talk about this change dy by dx, or if delta y by delta x at a particular point, this b which is here should tend towards this a. Correct? And this b for tending to a, this x plus h which is here, oh, I'm sorry, I'm moving the things. Okay, this x plus h which is here should tend towards this x. If x plus h is tending towards x, then what does h tends to? Means if x plus h value and x value are almost the same, what would be the value of h? 0. It's obvious, which means h should tend to 0. And you might have seen in the basic definitions of kinematics, which you have dealt basically, For very small changes of delta x, we write limit delta x tends to 0, limit delta x tends to 0, delta y by delta x is equal to dy by dx. Correct? In mathematical form, you might have seen this definition a lot of times when defining the definitions of velocity, acceleration, and all these things. Correct? Which means when this change delta x is very small, this delta y by delta x can be represented as dy by dx. Now, if I adopt this delta x tends to 0 condition over here at this point, what could I have? Limit delta x is nothing but h, correct? Because the change in between this x plus h and x is h. So instead of this delta x tends to 0, can I write h tends to 0? So h tends to 0, delta y by delta x is equal to limit h tends to 0, f of x plus h minus f of x divided by h, which is the, oh, again there is no sound. Am I audible to you? Nagasai, please look into the video now. I hope there is sound, correct? Okay, thank you. So when this limit is this one, which is dy by dx, this dy by dx is here, which we are talking, and this expression on the right hand side of this equation is here, which is basically the analysis of this, correct? So that's how this first principle of differentiation gets evolved. Now, the thing why I told you this, for the differentiation to exist, I have mentioned this function should be continuous. Why the function should be continuous at this point? Look, suppose if there is discontinuity at this point, okay, then did I change the curve? Okay, y is equal to f of x. So see here, or else, yeah, now it's fine, correct? So see here. Now, why this function should be continuous? That's the topic of discussion. Suppose if there is discontinuity at any point in between a and b, there is no smoothness for this point b to come to this point a. Correct? It will fall somewhere in between. So the function should be continuous for this whole analysis to get satisfied, and this x plus h to tend towards x, which is basically this delta x is turning to 0, and delta x is nothing but change in x, which is this h that we formulated here. Okay. Now we'll see where we use this differentiation in our real life, in our engineering applications and all these things. Take these notes. I hope you have copied some part of it during the mic problem. If you have taken this, I would enlarge you this part so that you could take notes of that. Slightly a bit, so you can, yeah. Now I hope you can take this part as well. I'll be giving you the link for the notes in the comment box today, as I have done it for the first video today. So you can get the notes of all these things over there again. Okay, so no issues if you lag a bit. Okay, now where we are using all these derivatives and all, could anyone Vijay Sai, how do we know the function is continuous or discontinuous? Simply you need to check the condition of the limit. You need to check for this condition, limit x tends to a, f of x is equal to f of a, and by some standards, some standard procedures, we'll evaluate this limit, and you know how to calculate this f of a. If both are equal, we say that limit is continuous. And don't worry, we'll be solving some problems as well on these concepts, so at that time you could be more clear. Okay, so next, okay, so how or where you are using these derivatives in your real life of engineering? Tell me any examples. Let us suppose you are from mechanical engineering, then where could you use these derivatives? Any guess? I'm looking for the comments. You better try something there. Okay. No comments. So you don't remember any place that you use derivatives. For example, I might have. I assume that all of you might have studied this. Okay, so I think all of you might have studied this basic kinematics in your class 11 and 12. Acceleration. What's the definition of acceleration? Rate of change of velocity, which is dv by dt. It's a derivative. Correct? Now, civil and mechanical engineering students, they generally deal with beams. So if you see the shear force and bending moment, mx, then you see this shear force is nothing but differentiation of this bending moment. ECE and EEE people, they deal with a lot of differential equations where they analyze some circuits and all. Similarly, CSE guys, they'll work out with probability. So see here, yeah, thermodynamics as well. A lot of points, ultimately a lot of points where you will be using all these things. Okay. So now let us go back to our discussion, the fight between minus a by b and minus b by a for slope of a straight line. Now, what does this derivative physically denote? For example, let us assume derivative of, we are in interest to evaluate derivative of f of x at x is equal to a. At x is equal to a. Again, my sound is not audible. Now it's audible for you people. Sound is not audible. It's audible now. It's showing white thing here. Okay, thank you. I think again there is an issue. Is it audible now? No, just a second. Yeah, I hope now it's audible. Correct? Okay, so see here. This mic is giving the trouble today, so it's fine. Okay, now it's audible. So see here, let us continue with the discussion. Now, derivative of function at x is equal to a. Now, if this is y is equal to f of x, if this particular value is x, then this is f of x. Okay? And if this particular value is a, what would be this value? F of a. Now, if I want to find the derivative of this f of x at x is equal to a, or at x tends to a, f dash of a, which is same as dy by dx at x is equal to a, is equal to f of x minus f of a, because the change in y is f of x minus f of a divided by the change in x is x minus a. This is the difference. And since we are talking at a point, this limit extends to a. So this is how you evaluate the derivative of any function f of x at a point a. And it's obvious, once you know how to evaluate these limits, you will check for the right hand limit as well as the left hand limit, and you see whether derivative exists or not. Now, see here. What does this f dash of a imply geometrically? What does this f dash of a imply geometrically? Yeah, there's a bit signal issues here, but we just rectified them. Now I hope I'm audible to all of you. Correct? Am I audible to all of you now? There's a small signal issue which we tested back. If I'm audible to you, please. Okay. Fine. Yeah. Slope at a point. Yes. This. Okay. Fine. I'm audible. Thank you. Now, what does this f dash of a geometrically denote? Now, for any function f of x, we'll find the derivative then we'll put the value x is equal to a and we'll get f dash of a. Now what this f dash of a geometrically cites us, okay? Once we have this f of x, we'll get this f dash of x at any point and f dash of a. Now what's the meaning of this? See here carefully. 0 x y, and let us suppose this is y is equal to f of x. Now let us suppose this is point A, x is equal to A. Now what does this f dash of A tells us? For example, if I draw a tangent here at this point, if I draw a tangent something like this, which could look something like this. Now see here, this tangent will be making some angle with positive x-axis. I mean in the positive sense with x-axis. Okay? This line will always make some angle with x-axis in positive sense. Let this angle be theta. Now one thing, if this point changes, if this line changes, tangent at this point will have some different orientation and this theta changes, correct? This is the particular orientation only when x is at this point A. Yes or no? When x gets shifted, this tangent orientation shifts. Suppose if this is the point, then tangent would have looked something like this. So which means when orientation changes, this theta changes. So this theta corresponds to only for this point A. So this f dash of A is nothing but tan theta. Tan theta. Okay. So once this A changes, this theta changes, and that's how you have different values of derivatives for the same function at different points. Okay. So now we'll get back to that line equation. Now tell me one thing, basically, suppose let us suppose there's a line which is passing through the points. Suppose if this is x and if this is y, if these are the points x1, y1, and if this is the point x2, y2, what is the slope of the line segment joining these 2 points A and B? If x1, y1 is the point A and if x2, y2 is the point B, then what's the slope of the segment joining this A and B? Some formulation for this slope of this line segment which is passing through the 2 points x1, y1 and x2, y2. Is there any answer for that? y2 minus y1 divided by x2 minus x1. Correct. Now how this y2 minus y1 or what this y2 minus y1 divided by x2, yeah, many of you are writing it correct. So what this y2 minus y1 divided by x2 minus x1 gives us? Look here. Let us have a look at it carefully. Y x 0, and let us suppose, and this is x-axis. Let me make it clear. X-axis. Okay. Now let me draw a straight line A B, or line segment basically, which is x1, y1, and the coordinates of this B is x2, y2. Okay. Yeah, y2 minus y1 divided by x2 minus x1. Now see here carefully. Now, if this point is x1, y1, if this point here is x1, y1, what is this distance denoted by white line? Basically the distance between this point and y-axis. What's the x1? Correct? It's obvious. This value is x1. Similarly, what is this value? This vertical line length y1. Similarly, what could be this length value? x2, and this could be y2. Correct? Yeah, correct. Now every length is clear. If I want to determine the length of this segment, which is here, what could be this value? y2 minus. Sorry. I think we made it a bit wrong. If this is y1 and this happened because of this writing y2 here, this length is y2, then this is x2 and this length is x1. So value of this length is x2 minus x1. Okay. Similarly, what could be if I consider a horizontal line like this? What could be this length? y2 minus y1. Okay. This length is x2 minus x1, the difference between the x coordinates, and this length is y2 minus y1, which is denoted by y coordinates basically. So now if you consider this angle as theta, What is tan theta from this triangle? This length is y2 minus y1 and this length is x2 minus x1. What is tan theta from this particular triangle AB, and let us suppose I have named it C. From triangle ABC, what's the length of, what's the tan theta value? y2 minus y1 by x2 minus x1. So tan theta is equal to y2 minus y1 divided by x2 minus x1, and this is the formula which many of you wrote when I asked you for the formula for slope, and this is slope which is denoted by m of a straight line. y2 minus y1 divided by x2 minus x1, and this value y2 minus y1 divided by x2 minus x1 is nothing but the tan of this theta, where theta is the angle here. And if you see, I could show you this theta is same as another theta which I could draw here for you, this theta, correct? Because if you see, these two lines are parallel lines and this is a transversal. So if this is theta, this is also a theta, and this theta is the angle made by this line with this axis, x-axis, correct? So that's why basically slope of any curve is nothing but the tan of the angle made by the tangent. Of course, for a straight line, the line itself is the tangent, so we don't bother much. So tan theta is equal to y2 minus y1 divided by x2 minus x1 is equal to m. And if you see, this y2 minus y1 is nothing but difference in y, and this x2 minus x1 is the difference in x. So this is dy by dx, and all these points are analogous to each other. So therefore, dy by dx at any point is equal to tan theta, where theta is the angle made by the tangent to the curve with x-axis in the positive sense. Now, when slope is tan theta, which is basically dy by dx, now if I write the equation ax plus by plus c is equal to 0, which could look something like this. Okay, why this? Ax plus by plus c is equal to 0 is the equation of a line which could look something like this. Now, if you differentiate this equation with respect to x, for example, if you differentiate derivative of ax, a is a constant, and derivative of x with respect to x is 1, plus b is again a constant into dy by dx plus 0, because differentiation of a constant is always 0, is equal to 0. So this implies dy by dx is equal to minus a by b, which is the slope of this line, but not minus b by a. Okay, so please take care of this. So generally, what does this slope represents to you? This f dash of a derivative at any point is nothing but the tan theta, where theta is the angle made by the line with the x-axis. Okay, I'll give you a moment. You can take all these things at a while. And these derivatives are actually of a lot of help for engineering applications. If you see, as I mentioned, the differences of a lot of quantities with respect to other, like one property is changing a bit, what about other property changing? How do you find it for second degree polynomial? Vijay, in a short time, I'll let you know. Okay, once you get the differentiation techniques. Now, taken this. If you didn't take this, you can pause the video for a moment, because we need to move ahead. Next. Now, if I ask you what's the differentiation of sin x, what's the answer? Derivative of sin x with respect to x. What could be the answer from your side? What's the derivative of sin x with respect to x? Cos x. Cos x. Fantastic. See here. So now we came to know one thing. F dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Okay. Now I told you this is the first principle of differentiation, and I also told you we can evaluate derivative of any function with the help of this limit which I wrote on the board. Okay. So now let me derive the derivative of sin x as cos x using this limit. I'll do it only for one function because we have some time constraints. So look at here. What is this f of x? Sin x that we are interested to find, right? We need to get what's the derivative of this sin x with respect to this limit. Now let us apply this. This implies f dash of x is equal to limit h tends to 0. Now tell me, if f of x is sin x, what is f of x plus h? If f of x is sin x, what is f of x plus h? Sin of x plus h, correct? Sin x plus h minus f of x is sin x divided by h. Now let us try to evaluate this limit. And I told you one thing, see here, if you go a few pages ahead, where we discussed this continuity definition, if we say a function is continuous, then limit always exists, correct? Because if I tell a function is continuous, then definitely limit should be equal to functional value, which means if a function is continuous, its ultimate that its limit is already existing. And yesterday you have seen sin x graph, there is no discontinuity for sin x. Sin x is a smooth continuous curve, so which means sin x is continuous at every point. So using that now here, limit h tends to 0. Now, what is sin a plus b formula? From your compound angles of trigonometry, what's the value of, or what's the formulation for sin x plus h? Sin x cos h minus cos x sin h minus this sin x sustains here divided by h. Correct? Now from both these expressions, let us take sin x common, which means I can write this limit as limit h tends to 0. Limit h tends to 0. If I take sin x common, we have cos h minus 1 divided by x, divided by h, plus there is one more limit h tends to 0. This minus cos x sin h is still here, so minus cos x into sin h, there's a plus sign here, sin x plus h, so this could be plus, so this is plus divided by h. Okay, yes, sin x cos y plus cos x sin y for sin x plus y. Okay, so now if you see here, the variable of limit is h, not x, because if you see here there is a limit h tends to 0, so the variable that is involved here is h but not x. When x is not a variable, this sin x is a constant. Okay? So I'm taking this sin x out of this limit, and if I write that sin x into limit h tends to 0 cos h minus 1 divided by h, plus again this cos x is a constant, so I could bring it out, cos x into limit h tends to 0 sin h by h. Correct? So now let me draw a partitioning line here, so you may not get confused. Let me, that's to the other side of the board. Okay, so it's clear now. So see here is equal to, now what's the value of this limit h tends to 0 sin h by h? It's known to us, the value of this limit h tends to 0 sin h by h, this value is 1, which means 1 into cos x is cos x plus, now if you evaluate this limit, one thing is clear, you could get the total derivative, because sin x into this value plus this cos x is the actual derivative of this sin x. And within a short time, I'll show you this limit h tends to 0 cos h minus 1, where h tends to 0, the answer for this is 0. Okay, so 0 into sin x plus 1 into cos x will give you cos x. I'll show you now why this limit h tends to 0, cos h minus 1 divided by h is h here. Okay, so that's how you can find derivative of any function using this first principle of differentiation. Now after this, I couldn't give you the derivations for all other functions, so I could give you the formulations directly, some standard derivative results. So some standard derivatives. Some standard derivatives. Okay, now first thing, d by dx of sin x. What's the derivative of sin x? Just now we have seen cos x. Correct? 2. What's the derivative of cos x? What's the derivative of cos x? Minus tan x. Minus sin x. D by dx of tan x is secant square x. Next, d by dx of cot x is minus cosecant square x. Cut. Next, 5. D by dx of secant x. What could be the answer for this? Secant x into tan x. And similarly, d by dx of cosecant x is, any guess from your side? What's the formula for differentiation of cosecant x? What's the formula for differentiation of cosecant x? Minus sin x. No, wrong. What's the differentiation of cosecant x? Minus cosecant x cot x. Okay, there should be a minus sign. Gayatri, take care of this minus sign. Cosecant x cot x. Okay, now these are basically 6. Yeah, Maurika Krishna, you got it right. So differentiation of this cosecant x is minus cosecant x cot x. So right now from this point, we finished all basic trigonometric ratios. Now let's go for the inverse functions of this. D by dx of sin inverse x. 1 by root of 1 minus x square. And of course, one thing is very clear. If you write sin inverse of something, this x always lies in between minus 1 and 1. Correct? And of course, this denominator doesn't get valid if x is more than 1, since we are getting negative numbers inside the root. So what's the difference of this, or what's the differentiation of this cos inverse x? Minus 1 by root of 1 minus x square. Again, where this is the case. Correct? 9. D by dx of tan inverse x. 1 by 1 plus x square. And x could be any value here, because tan changes from minus infinity to plus infinity, so there is no issues. So I'll give you a minute here to take all this 9 points, and later we'll go for some more differentiation formulas. Okay, you may take this. I think all these are basic, formulations that you could meet in class 12. Now, after completing of this, we'll go for some more differentiation formulas of some other functions. Yeah, tan inverse x derivative is 1 by 1 plus x square. It's correct, which I have mentioned there in the 9th point. You could see there. Now, shall we move ahead? Okay, you please pause the video if you didn't finish this and continue with me. Next, 10th. 10th point. D by dx of cot inverse x. What's the derivative of cot inverse x? Minus 1 by 1 plus x square. D by dx of secant inverse x. What's the answer for secant inverse x? I'll give you a minute time. So what if denominator gets infinity at x is equal to 0? Sin and cos inverse. If denominator gets infinity at x is equal to what did you say? 0. Slope is infinity means in general what's the case of that? Your y-axis means the tangent that you draw will get vertical at that point. Okay. Because if you see tan theta, value of tan 90, of course in the first quadrant itself is plus infinity. So if the tangent is vertical, then you'll get the slope as infinity, because tan 90 is infinite. Okay, Bhavin? Now, what's the answer for this? Basically, d by dx of 1 by 1 minus x square. No, wrong. See here. 1 by mod x into root of x square minus 1. Yes, correct, Monica Krishna. Next. What's the derivative of cosecant inverse of x? With a minus sign. Minus 1 by mod x into root of x square minus 1. And of course, this mod of x should be always greater than 1 for avoiding the negativity inside this square root. Correct? So these are some basic trigonometric ratios and their inverse functions for which we have seen the derivatives. Now, if I ask you d by dx to the base of, log of x to the base a, what could be the answer for this? And make a point clearly, there's a base a here but not e. Okay, so now write the answer by noting this point. Log x to the base a, it's not e. Please make a note and tell me the answer. 1 by x, yeah, that's what I told you. This is not e, it's a here. It's not a natural logarithm. You have a different base sitting here. Yes, 1 by x into log a to the base x. No, actually 1 by x into log a to the base e is the answer for this. Okay, yeah, 1 by x ln a, correct. 1 by x into ln a to the base e. And of course, you know, logarithms are defined only for positive values. Next, 14th. d by dx of log x to the base e. What could be the answer now? 1 by x, which you have stated before. Because if you put a is equal to e, log e to the base e value is 1. So 1 into x will give you x straight away here. Next. d by dx of a power x, where a is a constant. d by dx of a power x. What's the differentiation of a power x with respect to x? One by x, no. Derivative of a by a power x with respect to x. It's x log a, wrong. A into log a power log a power x. Yes, a power x into log a to the base e. So that's how derivative of e power x is again e power x. Because if you put e in place of a here, log e to the base e is again 1. So e power x is the derivative of this. So next, we finished logarithm functions, trigonometric, and now the very important polynomial functions. d by dx of x power n is n into x power n minus 1. And this is how we differentiate a polynomial function basically. A few moments back, someone was asking how to differentiate a second degree polynomial. Now, if we have n is equal to 2, this itself is a second degree polynomial. So we can put n is equal to 2 on the right hand side as well. So you'll get differentiation of x square is 2x. Next, what is the differentiation of a constant? d by dx of a constant. This is 0. Yes, 0, correct. I could give some moment for you to take these notes. Please take it. Yeah, all of you are writing. Shania, Socialize you, Harshita, all of you are writing it correct. Safi. So these are some techniques that we have. I will mention one more important function that we deal with generally. Okay, so we covered trigonometric, we covered inverse trigonometric, then logarithmic, exponential, and polynomial functions. Basically, the algebraic functions. Okay. Next. Okay, take it. I'll give you a moment. So what is e power x? It's monomial or polynomial. It's a polynomial function because I'll show in a short time. E power x involves terms like x square, x cube, x power 4, all these things. Okay, so it's not a monomial function. It has terms of different degrees, so it's a polynomial function, undoubtedly. Okay, Shall we move ahead? Now, one important function that I would like to discuss at this moment, d by dx of x power x. D by dx of x power x. What could be the answer? Does someone know it? I would leave it for you. Just make a comment in the box. Meanwhile, if someone didn't get a note, you could go here and try to find the derivative of x power x meanwhile when people are taking these notes. Yeah, I hope you can see the notes now. X power x into 1 plus log x. Correct. Abhiyam, correct. Monica, you are correct. So see here, the differentiation of this is x power x into 1 plus log x to the base e. Okay. Now, okay. So see here. Yeah, basically, yeah, I hope these 19 formulas could be of some good importance for you. And before going for that, for finding actual derivatives, I would like to give you a few things. Product rule of differentiation. Something happening on the screen. Product rule of differentiation. If there is product of two functions, f of x into g of x, then the product rule of differentiation that you follow here is first function into second function plus second function into derivative of first function. Okay, so this is how you generally differentiate product of two functions. Okay, so take this formulation, and there is also one more thing which is called the quotient rule, where you will try to differentiate the ratio of two functions. D by dxy of f of x divided by g of x is equal to, now, g of x into f dash of x minus f of x into g dash of x divided by g of x whole square. So this is how you differentiate a ratio of two functions, f of x divided by g of x. Please take this. Now, one important thing that I would like to discuss, as some of you are talking in the comments, generally when you differentiate an nth degree polynomial, the outcome that you will get is of n minus 1th degree. But when e power x is a polynomial function, then why the derivative of e power x is again e power x? It should be a power 1, I mean power less by 1. But the thing is, e power x is a polynomial function which is infinitely extending series. Correct? So as long as you keep on differentiating every succeeding term, the degree of the series keep on increasing, and that's how the derivative and the actual function will be looking like same values with one term difference. Okay, so that's how e power x derivative is again e power x mathematically, if you see. Of course, I would like to show you if it's needed at moments. I hope I'm blocking. Okay. Now it's clear. And coming to this basic calculus videos, you can regarding to this basic calculus, all +2 students can also visit this for getting some idea on concepts of continuity and all these things. Okay. Okay, Pavin, it's clear. Okay, so now I told you, now we have enough knowledge on derivatives. I would like to show you once again these things. So basically these are the differentiation formulas which you may not remember at a single go, but as time goes on, you could get to know of these things. Now, with the knowledge of these derivatives, I would like to work out few things on these limits, which I didn't discuss before. If you see, I told you after giving these limits, the standard limits which I mentioned in the beginning of the class today, somewhere here before this. Yeah, these limits, all these limits, I told you I'll be working out once I show you the derivatives, once I give you the knowledge of derivatives. So now we'll work out on that. Now if you see, first limits are this polynomial functions, then exponential, then various terms got involved anyhow. We'll see now how to evaluate this. Yeah, let me change the screens for a while. So, okay. So now here. So in limits, so see here. There is one very important rule in limits which is called the L'Hospital rule. L'Hospital is the name of the person that's associated with this rule, and this L'Hospital rule is something like, if limit x tends to a, let me write it clearly, limit x tends to a, f of x by g of x, means basically when I'm substituting ES here, if f of a by g of a is giving you either 0 by 0 or infinity by infinity, then limit x tends to a, f of x divided by g of x is same as f dash of a divided by g dash of a, provided g dash of a is not is equal to 0 and f dash of a is also not equal to 0. Again, you should not get this 0 by 0 form. Now, if once again you are getting this 0 by 0 form, means if f dash of a by g dash of a is also 0 by 0, then limit x tends to a, f of x by g of x is equal to f double dash of a divided by g double dash of a. And again, for writing this, your g double dash of a should not be equal to z, this g double dash of a should not be equal to 0 alone. Okay. Now, after discussing Taylor series, I'll show you how this L'Hospital rule is evaluated or evolved. I'll show you the derivation of this, which is on just a couple of steps, but you need the knowledge of Taylor series for doing that. Okay. So right now, if you're getting 0 by 0 or infinity by infinity forms, you should keep on differentiating the functions until you get a finite, some finite value. Now, thing is, yeah, basically that's the thing. One important thing that you should take care of here is, if you see, I am differentiating the functions individually. Means I have differentiated f of x separately, and I have also differentiated this g of x separately. I haven't used the quotient tool here, correct? I didn't use the quotient tool for differentiating these functions. You should not use that. You should differentiate the functions individually. Derivative of this function, put it here. Derivative of this function, put it here. But not f of x by g of x quotient tool. Okay, please take care of this and take the notes of this. Meanwhile, I'll be standing here so you could see the notes. I could push it a bit. Yeah, okay. I hope it's clear. Okay, so now with this knowledge, we'll try to work out a few examples that we discussed. I mean, the few results that we discussed. Okay, now first one. Let me click this. First one. Limit x tends to a, x power n minus a power n divided by x minus a. Right. Now, if you put this a here, definitely this a power n minus a power n, you are getting 0, and also if you put a here, a minus a is also 0, which means you are getting 0 by 0 form. So now, can we apply this L'Hospital rule here? Yeah, if you apply, this is equal to limit x tends to a, and please make a note, you can apply L'Hospital rule only if you are getting 0 by 0 or infinity by infinity forms. Okay, and in this case, you are getting since 0 by 0. Let us see this. You can differentiate this function separately. Differentiation of x power n. Differentiation of x power n. What's the differentiation of x power n? Just now we have seen n into x power n minus 1 minus differentiation of a power n. You know both a and n are constants, so a power n is also a constant, and derivative of the constant is 0, divided by differentiation of this x is 1 minus derivative of this a is 0, So this is equal to, when you substitute a here, n into a power n minus 1 divided by 1, which is the answer for this. Therefore, limit x tends to a, x power n minus a power n divided by x minus a is equal to n into a to the power n minus 1. Okay, which I have stated in the first result, you could see. Next, now shall I give you a question? You could give it try further and tell me the answer. See here, limit x tends to 8, x power 1 by 3 minus 2 divided by x minus 2, or x minus 8, you could write here. What's the value of this limit? Hello Vishal, please find the answer for this limit. Okay. What's the answer for this? You could give it right within some 2 minutes. Meanwhile, you can take this if you didn't. Of course, it is just a simple analysis. If you understand the hospital rule, it's a simple thing. 1 by 12 summa, power it's 4. Okay. One by 12, yes, 1 by 12 is the answer. Simple thing, if you substitute 8 here, you will be getting 8 power 1 by 3 is 2. So 2 minus 2 is 0. And similarly, this denominator also tends to 0. So you could apply L hospital rule. So x tends to 8, 1 by 3 into x power 1 by 3 minus 1 will give you minus 2 by 3. Let me write this minus sign clearly so you could see. Well, minus 2 by 3 minus this differentiation of this 2 is 0 divided by differentiation of this x with respect to x is 1 minus differentiation of 8 is 0. So if you put x is equal to 8 here, 1 by 3 into 8 power minus 2 by 3. And how to evaluate this value, 8 power minus 2 by 3? So 1 by 3 into this 8 can be written as 2 cube. So 2 cube whole power minus 2 by 3. So this 3 gets cancelled. And 2 power minus 2 can be written as 1 by 2 square. So 1 by 3 into 1 by 4 will give you 1 by 12. Or else if you adopt this particular formulation also, you could get the answer. You might have written this 2 as 8 power 1 by 3. Then n into a power n minus 1 could be the answer direct. You would have achieved this step since both are interlinked. Yeah, I'm happy all of you got the right answer, 1 by 12. Yeah, so many of you got the right answer. Good. Revati, Venkatanaka, Gayatri, Gauri, Monica, Krishna, Paveen. Good. All of you have got it right. Now, let us go for the next limit. Limit x tends to a, x power n minus a power n divided by x power m minus a power m. The answer for this is n by m into a power m n minus m. So now, how to evaluate, how to show this result? We have seen if limit x tends to a, x power n minus a power n by x minus a is here, then we got n into a power n minus 1. So to get this, let us see here. Can I make a small modification here, which you may allow me to do, divided by x minus a whole divided by limit x power m minus a power m divided by x minus a. Can we do this? So that we could cancel this x minus a and we could still retain this term, which is here. And I told you clearly, if there is limit x tends to a, f of x divided by g of x, we could write the limits separately for each case. So which means I could write here limit x tends to a, x power n minus a power n divided by x minus a divided by limit x tends to a, x power m minus a power m divided by x minus a. Now you know well than me what's the answer of this limit, because you have seen it just now. So the answer for the limit on the numerator is n into a power n minus 1 divided by m into a power m minus 1. So which is, this n is on the top and m is at the bottom. So this could be, something happened, is equal to n by m into, now this a power n by 1 divided by a power m minus 1 could give you a power n minus 1 minus of m minus 1. So this minus 1 gets cancelled, and you have a power n minus m here, which is n by m into a power n minus m. Clear? This is how we evaluate this limit. Okay. Okay, shall we move ahead? This is just a simple manipulation of writing this x minus a, or you could directly apply the L'Hospital rule here itself, because you will get 0 by 0 form. Okay. Next. Limit x tends to 0 sin x by x. Now if you put 0 here, sin 0 is 0 and denominator is also 0. So we will be getting 0 by 0 form. So if you apply L'Hospital rule to this, limit x tends to 0, derivative of sin x is cos x. Just now we have seen the derivation of it well. Differentiation of x is, with differentiation of this x with respect to x is 1. So when I substitute this x is equal to 0, cos 0 is 1. Okay. So this is how limit x tends to 0, sin x by x is equal to 1. Okay. Next. Similarly, now could you work it out for the tan x? For tan x by x also, you will be getting 0 by 0. So if you apply L'Hospital, you will be getting 1. So I am not doing it here, which you could write out. Next. Limit x tends to 0, sin inverse x by x. Again, when x tends to 0, sin inverse x tends to 0, because sin 0 is 0. So sin inverse of 0 is also 0 divided by 0. So this is giving you 0 by 0 form. So this is equal to limit x tends to 0. If you apply L'Hospital rule, we'll be getting differentiation of sin inverse x is 1 by root of 1 minus x squared divided by, when differentiation of x with respect to x is 1. So which is basically limit x tends to 0, 1 by root of 1 minus x squared. And if you put x is equal to 0 here, you'll be getting 1. Okay. So sin inverse of x by x. Therefore, limit x tends to 0, is equal to 1. Yes. Gauri, it's correct. It's 1. Just it's all just a basic application of this L'Hospital rule. Now, I would like to introduce you something called indeterminate forms. Indeterminate forms means generally it's not necessary that you'll always be getting 0 by 0 forms or infinity by infinity forms. There could be some other forms which you could get, like 0 power infinity, infinity power 0, 1 power infinity, and infinity minus infinity, 0 into infinity, things like this, which are not like simple analysis. So how to evaluate these kind of limits? If your limits are getting into one of this form, how to evaluate? Let us try to see. Now let us discuss a case if it's giving power forms of indeterminate forms. Like if you see, these are power functions which are of indeterminate forms. So see here. First, let us start with the limit that I gave you, 1 plus ax whole power 1 by x. Okay. Now if you substitute 0 here, it is one thing that's very much sure. 0 power infinity is the answer that you will be going to get, because if you put 0 here, 1 plus 0 is 0 and 1 by 0 is infinity, of course, with a sign change depending on the right or left interval, doesn't matter. So you are getting this first indeterminate form as 0 power infinity. Now let us see how to work out such questions. What's the answer for this? Okay. Now to evaluate this, let y is equal to 1 plus ax whole power 1 by x. Okay, so if you apply logarithm here on both sides, log y to the base e is equal to log of 1 plus ax. This plus is always making some issue. 1 plus ax whole power 1 by x to the base e. And log of x power something, then this something which is on the top of this number can be written as a multiplication here, which means log y to the base e is equal to this 1 by x, if it comes here, 1 by x into log of 1 plus ax to the base e. because this 1 by x is on the top of this. So when you apply logarithm, this can be written forward. Now if you see, log y to the base e is equal to log of 1 plus ax to the base e divided by x. Correct? Because this 1 by x, which is in multiplication here, can be written in this format. So this implies, now if you apply limit on both sides, limit x tends to 0, which we are interested to find out, limit x tends to 0, log ye is equal to limit x tends to 0, log of 1 plus ax to the base e divided by x. Okay. Now if you substitute 0 here, this 1 plus 0, log 1, we know value of log 1 is 0, we have discussed in yesterday's class, and if you put x is equal to 0 here, now we are getting this limit as 0 by 0, for which we could apply our standard L'Hospital rule. Okay. Let me do that. So this limit and log are interchangeable functions. There is no issue. If I write log of limit or limit of log, both could give me same value. So I could write log of limit x tends to 0, y to the base e is equal to, then evaluating this limit, the differentiation of log of this complete function is limit x tends to 0. Now the derivative of this log of 1 plus ax is 1 by 1 plus ax into inner derivative of this 1 plus ax is a, because derivative of 1 is 0, 0 plus differentiation of ax with respect to x is a divided by derivative of this x is 1. Now if you put 0 here, then 1 by a 1 plus a into 0, this whole value in the bracket will give you 1, and this is equal to a. So the right hand side of this expression is equal to a. So finally we got log of limit x tends to 0, y to the base e is equal to a. So what could be limit x tends to 0 by e power a? Correct? So let me write that limit x tends to 0, y is equal to e power a, and let me highlight this because this is the final result. And what is y? As per our initial substitution, y is 1 plus ax whole power 1 by x. So if I put 1 plus ax whole power 1 by x, then LHS of this equation is this, for which the answer is e power a. But in GATE examination, we don't have this much time to evaluate or to analyze all these things. So there is one shortcut for this, let me tell you. But before telling that, you should take care of this. Take a note of this. And whenever you get power infinity, 0 power infinity, infinity power 0, 1 power infinity, apply two L's. One L stands for logarithm, which I applied here. And second L stands for L'Hospital rule, which I applied here. Okay. So if you are getting indeterminate forms of powers, first of all, apply this logarithm, then apply infinite. One power infinity is not 1 because you will write power only if you know how many times you are multiplying. If I write suppose a square, I know that I am multiplying this here 2 times and I could give you the value. But if I write infinity on the top, I don't know how many times I should multiply it. So I can't give you a finite value for that. Okay. So 1 power infinity is not 1. If you can, you can fight with me for a simple reason. Like how many times you keep on multiplying 1, you'll still be getting 1. Then I'll ask you, tell me the how many times is that how many times. Okay. Yeah. Okay. Now after taking this, I'll let you know what's the shortcut and all. Okay. So please take this analysis, because generally shortcuts might not be available. And one thing I would like to suggest you for GATE examination, never touch on shortcuts, because for example, let us suppose for one subject you have some 30 shortcuts. Then for 15 subjects, finally you will be getting some 450 shortcuts, which I'm sure that you won't remember in the GATE exam on the day of exam. Okay. And also standard quizzes are always the best, because in shortcuts, if you remember some terms or if you remember this plus or minus sign, then your story changes. And trust me, for every one mistake you make in GATE examination, you're going to lose ranks by some big numbers. Okay. Apply 2 L's whenever you're getting power forms of indeterminate forms, log and L'Hospital rule. Okay. Now, shall we move ahead? Now, let us consider the same example. Limit x tends to 0, 1 plus ax whole power 1 by x. And we know the answer we got just now for this is e power a, and that's what I mentioned earlier. Now shortcut is, if limit x tends to a, f of x power g of x is giving you 1 power infinity form, then limit x tends to a, f of x power g of x is equal to e power limit x tends to a, g of x into f of x minus 1. This is the standard shortcut that you could have for analyzing this 1 power infinity situations here. So, okay. So now if you try this model for this particular problem, now see here, this implies limit x tends to a, 1 plus ax whole power 1 by x, which could give me 1 power infinity form when I evaluate it, is equal to, okay, let me not put the is equal to sign. This is just for your understanding. So this is giving you 1 power infinity sign. We can apply here e power limit x tends to a, which means x tends to 0, which I put here. Let me put here also. X tends to 0, 1 plus ax whole power 1 by x, which is giving you 1 power infinity form. So this is equal to e power limit x tends to 0. What is g of x out of these two functions? Out of 1 plus ax and 1 by x, what is g of x? 1 by x, correct? So 1 by x into, what is f of x? 1 plus ax. 1 plus ax minus 1. So this 1 gets cancelled here, and which is equal to e power limit x tends to 0, 1 by x into ax. So this x gets cancelled, and a is a constant, and limit of that a is a again. So we have e power a, which we can analyze in this way as well. Okay. So this is the trick that you can use when you are getting the things only in 1 power infinity format. Okay. You can't use L-Hospital rule for this kind of indeterminate forms. Okay. So please make a note of this. Actually, this is really important that I could make it under a box if you could wish. Now, after some basic theory that we learn like this, we'll go for a few gate problems that we worked out actually. So we'll work out in the class. You work out along with me so that we could get the answers. Okay. Now, limit x tends to infinite, 1 plus a by x whole power x. I told you the answer for this is also e power a. Correct? Now with the knowledge I gave you, try this question and tell me whether you are getting this answer or not. Because if you put infinity here, some finite number divided by infinity is 0. So 1 plus 0 is 1. 1 power infinity form. So you can work out with the previous analogy that I taught you. And we are planning like this currently on weekdays from Monday to Saturday. We'll be giving a lecture of 1.5 hours nearly from 7:45 a.m. to 9:15 a.m. But on Sundays, we'll go for a slight larger lecture from 7:45 to 11:45. So that it's already 10 o'clock, I guess. Yeah, quarter to 10 nearly. So that we could complete the syllabus in hand. Because it's equally important that you should have enough time for revision after the syllabus gets completed. Okay. Okay, so I hope you might have got the answer, e power a. Did you all get it? How many of you got it? No one got it. I can't see any comments in the box. Got it? Yeah, good. Fine. Yeah, okay. Whoever didn't get it, you can see. This is, since this is giving 1 power infinity format, e power limit x tends to infinity g of x, which is x here, into f of x minus 1. Then this 1 gets cancelled, and again by cancelling x's here, you will be getting e power a directly. Okay. Next. So at this moment, we have learned how to calculate some important limits that we worked out actually. Before going for one standard or one last limit, I would like to give you another limit. A power x minus 1 by x. If you see, we are getting 0 by 0 form here for this limit as well. Correct? Okay. So if you apply L'Hospital rule, simply a power x, the differentiation of a power x is a power x into log a to the base e minus derivative of 1 is 0 divided by derivative of x with respect to x is 1. So if you put x is equal to if you put x is equal to 0 here, you got 1 into log a to the base e, which is log a. Yes, correct. Log a to the base e is the answer, which I have given you earlier. Now with the help of this limit, I would like to prove the 13th point that I gave you there, which is a power x plus b power x by 2 whole power 1 by x. Okay, so let us see that. Did you all understand this? It's just a 0 by 0 form, simple form, and you could apply the L'Hospital once. That could make a big sense here. So with the help of this limit, I would like to show you how this is, this is 1 by x. Is cube root of ABC. Let me show you this result, then we'll work out few gate problems which we generally solve here. Okay. So this is the last limit that I will tell you now. Now we have seen one thing very clearly. Limit x tends to 0, a power x minus 1 by x is equal to log a to the base e. Okay? This is what we have seen in the previous moment. So now if you see here, if you put x is equal to 0, a power 0 is 1 plus b power 0 is 1 plus c power 0 is also 1. So 1 plus 1 plus 1 will give you 3. When it's divided by 3, this bracketed term gives a value of 1. And when you put x is equal to 0, this 1 by 0 tends to infinity. It's of course. So it's of the form 1 power infinity. So applying a shortcut notation that we adopted, e power limit x tends to 0, let me enlarge this, e power limit x tends to 0, g of x, which is 1 by x, into f of x minus 1. A power x plus b power x plus c power x divided by 3 minus 1. This is the limit that we are going to evaluate now. So this is equal to e power limit x tends to 0. Now see carefully. Can I take LCM here? If I take LCM, I'll be having a power x plus b power x plus c power x minus 3 divided by 3x. Okay? Of course, this x comes from here. We multiplied inside the bracket. So this minus 3 can be slightly adjusted to a moment like limit x tends to 0. Writing the terms separately, a power x minus 1 by 3x plus b power x minus 1 by 3x plus c power x minus 1 by 3x. Correct? Because if you see, the denominator is same, and if you add upon all numerators, you'll be getting a power x plus b power x plus c power x plus all these minus 1s contribute to minus 3. So this is equal to, now since 3 is constant everywhere, you could bring out that 3 out of this limit because this 1 by 3 is a constant. So e power 1 by 3 into, now can I apply the limits individually for each term? Because we know that limit can be split up at all mathematical operators like plus and minus. So limit x tends to 0, a power x minus 1 by x plus limit x tends to 0, b power x minus 1 by x plus limit x tends to 0, c power x minus 1 by x. This is what we have inside the limit. Now, if you use this result now, what's the value of this limit x tends to 0, a power x minus 1 by x, which we obtained here, log a to the base e. So this is equal to e power 1 by 3 into, the answer of this limit is log a to the base e, which I'm writing ln, natural logarithm, plus ln b for the second limit, plus ln c corresponding to the third limit. Okay? So this is equal to e power 1 by 3 into Ln A plus ln B plus ln C can be written as ln of ABC, because in logarithms we have a property that log of product of two quantities is equal to log of first quantity plus log of second quantity. So if you use that, we got ln ABC. And since this is to the logarithm, and this is in the multiplication to the logarithm, we can pull this 1 by 3 to the top of this, as we are getting this 1 by x here. Okay. So again, if I put back this 1 by x here inside the log, then we could write e power ln of ABC whole power 1 by 3. And ln of something when there is power e is again ABC whole power 1 by 3, which is cube root of ABC that we discussed. Okay, so that's how the answer of this is ABC. If there are only two elements, this 3 might not exist here, then we might have got square root of ABC. Correct? So like this, if there are n elements, this is nth root of and factorial in general, because this question was asked many times in GATE with different number of quantities here. Okay, so please take care of this. And if you somewhere, if you could feel difficulty in logarithms, you could I would like to give you few steps of logarithms, few properties of logarithms right now. And my friends, please be careful. This is c power x. Okay, c power x. That's not e. Okay. Take it. Done. If done, please type yes, because this limit is really important as far as GATE is concerned. Okay. If you know this result directly, you need not do all these analysis. If I put numbers like 2, 3, 4 here, you could get the things here. And one thing I would like to advise you, when you are evaluating such values, when numericals are involved, please use some virtual calculator. Okay, because virtual calculator is the main thing that plays a role in GATE examination. Because the normal difference between Casio and this virtual calculator is really big. So I advise you strongly to use this virtual calculator for analyzing the quantities like this. Okay, taken. So now we'll move for the problems on limits. Well, this is the first limit. So try to find the limit. It was asked in 2007 by us, by GATE examination people. So you could give a try for this limit. What's the answer for this? One. No, it's not 1. Try. It's a good limit. 1 by 6. Yes, the answer is 1 by 6. Now let us try to see how it's 1 by 6. Okay. First thing, let us adopt the standard procedure that we adopted for. Limit x tends to 0, e power 0. Okay, let me write the question once. E power x minus 1 plus x by 1 factorial plus x square by 2 factorial divided by x cube. So if you put x is equal to 0, this e power 0 is 1 minus 1 plus 1 plus 1. I mean 1 plus 1 by, this is 1 plus, if you put x is equal to 0, 0 by 1 factorial is 0 and 0 by 2 factorial is also 0. So this total is 0 divided by 0. So this is 0 by 0 form. So if you apply L'Hospital rule, which you could work out, limit x tends to 0, e power x, differentiation of e power x is e power x, we have seen, minus derivative of 1 with respect to x is 0. plus derivative of x with respect to x is 1, and 1 by 1 factorial will give you 1, plus derivative of x square is 2x, because differentiation of x power n is n into x power n minus 1. So x square is 2 into x power 2 minus 1 divided by 2 factorial divided by this x cube will give me 3x square. Okay, so this 2 factorial 2 gets cancelled because value of 2 factorial is 2. It's obvious. Okay, so this is equal to limit x tends to 0 e power x minus 1 plus x by 3x square. Now again, if you substitute 0, again you will be getting 0 by 0 form. So this is the second step. So this is equal to limit x tends to 0. Again, if you apply differentiation for one more time, derivative of this is e power x minus derivative of this 1 plus x is 1 divided by differentiation of this 3x square is 6x. So now if you bring out this 6 constant out, so 1 by 6 into limit x tends to 0 e power x minus 1 by x. This is something different, e power x minus 1 by x. So this value is 1. So 1 into 1 by 6 is 1 by 6. Now one thing many of you might have understood by this time, I'm using the standard procedure because I didn't give you the expansion of e power x till this moment. Okay, if you might have known the expansion of e power x, this question might have been a bit shorter for you. Now without that expansion, this is the standard procedure with which I have discussed it till this moment, that you could evaluate the answer 1 by 6 here, and the answer is option B, which was asked in GATE examination. And now let me go back a bit. Yeah. Okay, so at this moment, I would like to give you a few expansions. Before going for a few expansions, I would like to give you some logarithm properties which you could work out. Log of x power n to the base a is equal to n into log x to the base a, and log of a power log x to the base a is again x. Log of ab to the base e is equal to log a to the base e plus log b to the base e. Similarly, these are just basic things, but if you are not aware of this, no problem, you can take it from here. Log a to the base e minus log b to the base e. Okay, so these are few properties that you would divide. That you could make a note of these things. Now, along with these logarithm properties, I would like to give you a few expansions as well. For example, e power x expansion about x is equal to 0, which I would derive in Taylor series. But for the right now, if you take this series, this e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on. This is the expansion that you get for e power x. Similarly, for sin x is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial and so on like this. It's basically the coefficients involving odd factorials and odd powers with alternating plus and minus sign. Similarly, for cos x, if you try to write expansion, 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus x power 8 by 8 factorial and so on. Okay, so now I'll show you how all these three expansions, how they are being written like this when I dilute Taylor series. But right now I would like to explain one thing very clearly at this point. So if you see the expansion of sin x, what's the expansion of sin x that we have written there? X minus x cubed by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus and so on like this, correct? Now, many of times in your engineering on your, basically in your +2 class physics, if you remember, when you are deriving the time period of a simple pendulum, you'll be writing for small theta, sin theta is almost equal to theta. Do you remember writing this expression anywhere in your life till now? And mechanical people, when they are dealing with stresses in beams, they'll write this. They'll use this approximation. When theta is very small, sin theta is almost equal to theta. You remember? Any of you? Pavani, yeah, you remember. See here. Now, why this sin theta is almost equal to theta when theta is very small? Look here. When theta is very small, basically like 0.1 radians, 0.2 radians and all. When theta, or here if you see, since I'm dealing in x, let me write, when x is very small. When x is very small, what could be the value of x cube? Is it more than x or less than x? When x is less than 1. It is more or less? Less than, correct? It's of course it's less than. So when x is very small, this x cube is still more smaller than x. For example, if we see, if you take x is 0.2, x square could be 0.04, which is very much smaller than this. Okay? Similarly, when x is less than 1 or when x is very small, this higher order terms are furthermore less than the actual term. So, very small term divided by 3 factorial. 3 factorial is considerably big. 6 value is 6 and 5 factorial is 120. 7 factorial is beyond that, 720 and 8040 and something, all these 5040, all these things. So, when x is very small, all these terms which I am writing here, x cubed by 3 factorial, x power 5 by 5 factorial, x power 7 by 7 factorial, all these terms are neglected because they are very small to each other, correct? So which means when x is very small, this sin x is almost equal to x, because see, I'm not putting the sign equal to here, okay? It's almost equal to, because even though they are very, very small, but of course they do have some importance there. Sin x is almost equal to x. If sin x is almost equal to x, then this implies, what is sin x by x almost equal to? 1, correct? Because if sin x is almost equal to x, the ratio of these two will near 1, and this is happening when x is very small, means basically when x tends to 0, correct? When x is very small means basically when x is almost 0, then this sin x by x is almost equal to 1. This means when this x is tending to 0, this sin x by x value is tending to 1, and that's how mathematically we write limit x tends to 0, sin x by x is 1. Okay. This is how one other way of showing this limit, and this is the basic explanation why when theta is small, you have used this in your school level and all beyond that. Okay, is that clear so far? Any questions anywhere? It's understandable, I hope so. Take it. Okay. So now if you see, this is the expansion of e power x. So if you go back a moment, now again if you see this question once again, we have applied L'Hospital 3 times before to evaluate this limit, but there is no actually necessity of applying 3 times. If you know the expansion of e power x, can we write, oh sorry for this, can we write limit x tends to 0, in place of e power x, if I write the expansion of e power x, 1 plus x by 1 factorial plus x square by 2 factorial plus x cubed by 3 factorial and so on like this, minus 1 plus 1 plus x by 1 factorial plus x square by 2 factorial divided by x cube. Can we write it like this? Because once you know the expansion of e power x, now if you see clearly, these first 3 terms are common in both these terms. Correct? So we can cancel this because there is a minus sign over here. So if you cancel these terms, which is limit x tends to 0. Now see carefully. This is x cubed by 3 factorial. What could be the next term? It's x power 4 by 4 factorial. And the next term beyond that could be x power 5 by 5 factorial. Which means from the terms that are starting here, every term has x cube in the numerator. Correct? One x cube in the numerator, and we can take out that common. So if you take that common x cube into, this is 1 by 3 factorial plus, next term is x power 4 by 4 factorial, but when you take out one x cube common, you still have x by 4 factorial plus x power x2 by 5 factorial and so on like this, divided by x cube. So this x cube gets cancelled. Okay? There's no issue with this denominator now. So now when you substitute this x is equal to 0, apart from this 1 by 3 factorial, all other terms to the right goes to 0. So which means we are left with only 1 by 3 factorial, which is 1 by 6. And that's the answer that we got when we applied our standard L'Hospital rule. Okay, so please take care of such little things which could shorter your solutions. Okay, and of course by practicing a lot of times, they'll all get in hand with you. Okay, clear? Just applying, writing the expansion of e power x, then cancelling the common terms, taking an x cube out of it, then cancelling and writing out the things here. Okay, so shall we move back to our actual problems? Look at this question now. Try and tell me the answer. What could be the answer for this? It was asked in 2016, and that year was a remarkable year in the history of GATE because it was organized by IIT Bangalore, and we can see a lot of good questions in the paper in concerned subjects. D1, is that the answer? Let us wait for other comments. B, C, B. Okay, I hope some fight is going on. Let us see what's the value. I hope it should be 1 by 12. Let us see. Now, if you apply this limit x tends to 0, log of 1 plus 4x to the base e divided by e power 3x minus 1. This is the limit that we have. See, you are getting 4 by 3. Okay, then I might be doing wrong. See here, log of 1 plus 4x to the base e, to the base e divided by e power 3x minus 1. Now, if I put x is equal to 0, this 4 into 0 could give me 0. So 1 plus 0 is 1. Log 1 to the base e is 0 divided by, if I put x is equal to 0, 3 into 0 is again 0 and e power 0 is 1. So 1 minus 1 will again give me 0, which means it's basically giving 0 by 0 point, which means we can apply our standard L'Hospital rule. So if you apply that, limit x tends to 0, what's the derivative of this log of 1 plus 4x to the base e? 1 by 1 plus 4x into the inner derivative of this 1 plus 4x is 4 divided by, what could be the derivative of this e power 3x? E power 3x into 3 minus 0, because differentiation of this one is 0 with respect to x. So now if you substitute this x is equal to 0 here, if you substitute 0 here, 1 by 1 plus 4 into 0, this 4 into 0 is 0 and plus 1, this total denominator is 1 and this whole bracketed term value converges to 1. So 1 into 4 is 4 divided by, if you put x is equal to 0 here in place of this 3x, then 3 into 0 is 0, e power 0 is 1 and 1 into 3 would still give you 3. So the answer is 4 by 3, which is option C. And yeah, many of you are getting it correct. So the answer is 4 by 3, just application of L'Hospital once. Okay. Okay, so if you applied L'Hospital just once, you could get the answer as 4 by 3. Next. Can we go? Can we go for the next slide? Okay. I hope you got 4/3 just applying L hospital once. Okay. So shall we go for next slide? This is really an important question which was asked in many times in GATE examination. Now try to get the answer for this question. I would give you some 1 or 2 minutes. Try to answer this question. What's the difference between sequence and series? If you could know that difference, you could have worked out this question. What's the answer for this? The limit of the following sequence as n tends to infinity is xn is equal to n power 1 by n. It came in 2015 computer science, so that you can, work out the things. Okay. Any answers from your side? B, answer is 1. Okay, see here. First of all, any sequence can be characterized by its nth term. Means, for example, if I write x, sorry for this, xn is equal to some n, which means I have a sequence like 1, 2, 3, 4, 5, 6, and 7, and so on like this. Because first term x1 is when n is equal to 1, you should put 1 here. Second term, when n is equal to 2, you should put 2. So this is how you generate a sequence. So generally, you can define any sequence by defining the nth term. But in this case, it's given xn is equal to n power 1 by n. Means basically when n tends to infinity, means after writing this is 1 power 1 by 1, 1 power 1 by 2, 1 power 1 by 3, and so on for a longer level. What could be the value of this? Means basically this question is asking limit n tends to infinity, n power 1 by n. What's the value of this? This is what he's asking for in this question. Okay, so this is the limit when n tends to infinity. So if you try to work out, now let us see. Let me clear this for a while so that we can have some more space to write. Okay. So see now, limit n tends to infinity, n power 1 by n. Now this is of the form infinity power 0, correct? Which is again a power form which is of undeterminate format. I told you if you are getting indeterminate forms of power forms, apply 2 L's. One is logarithm and the second is L'Hospital rule. So let us apply that here. Let y is equal to n power 1 by n. So this implies log y to the base e is equal to 1 by n into log log n to the base e. Correct. This is what we'll get here. So this implies if you apply limit n tends to infinity here, log y to the base e is equal to limit n tends to infinity log n to the base e divided by n. Correct. Now one thing, this base e is greater than 1, and I told you whenever this base e is greater than 1, graph looks something like this. In yesterday's class we have seen. Correct. So when base is more than 1, so when n is tending to infinity, means when this n is tending to infinity, this f of x means the log value also tends to infinity. So this value is infinity by, since n is tending to infinity, this value is also infinity. So infinity by infinity form. Now you could apply your simple L'Hospital rule to work out this. So log of, just I am interchanging this log and limit. So log of limit n tends to infinity y to the base e is equal to, now if you apply L'Hospital rule here, limit n tends to infinity, differentiation of log n to the base e with respect to n is 1 by n divided by differentiation of n is 1. So which means limit n tends to infinity 1 by n, which is 0, because 1 by infinity will give you 0. Infinity is the symbol for writing a very large number. So 1 by that very large number will give you 0. So which means this limit n tends to infinity y is equal to e to the power 0, which is 1. So this is the final answer that we could get here. So the answer of this is 1, option B. Okay. But this question was asked nearly some 3 to 4 times with different formats. One time it was asked in this format in 2015, and some other year it was asked the limit extends to infinity x power 1 by x in such way. It was asked in a lot of different forms in GATE examination. You could take a note of this in a moment. I could wait for you, and whoever got it, I'm happy for you. Clear? So, shall we move ahead? Whenever I'm repeating, whenever you are getting indeterminate forms in power forms, apply 2 L's. 1 L stands for logarithm, and second L stands for L'Hospital. That we applied here in this case. Okay. Okay, so now moving ahead. What could be the answer for this limit? Good, Gayatri. What could be the answer for this limit? Limit extends to infinity x minus sin x divided by x plus cos x. L'Hospital, yeah, of course, you could apply L'Hospital. No, it's not 1. Yeah, it's 1, of course. Sorry for that. It's 1, Suma. You are correct. So meanwhile, try out this question. There's a clash between 2 other lectures. So we will be stopping this lecture at this moment for today. And notes for this lecture will be uploaded. The link for notes of this lecture will be uploaded in the comment box of this video. So we'll stop this lecture here for now, as it's more than 10:15. There's another lecture for our students. So we'll stop this. Answer for this is 1. And in tomorrow's class, I would show you. In tomorrow's class, I would show you how this is 1, and I also give you some technique for this so that you could tell the answer directly. Okay, so we'll stop it here for now. Meanwhile, for tomorrow's class, you could try out this question and come for tomorrow's class. Okay. Fine. Then thank you all. We'll meet tomorrow at 7:45 a.m. sharp again here. Thank you all.